The dawn of detection, the early development of radar. Welcome to Lost Pages of Science. Today we travel back to a time when the ability to see without sight was merely a dream, a time when scientists and engineers dared to harness invisible radio waves to detect what lay hidden in the dark. Imagine a world before satellites and high-tech sensors, where the very concept of detecting distant objects through the air was a revolutionary idea. This is the story of the early development of radar, a breakthrough technology that transformed warfare, aviation, weather forecasting, and much more. Our journey begins in the early decades of the 20th century, when radio technology was still in its infancy. It was a time of experimentation and bold ideas, where the invisible world of electromagnetic waves held untold potential. Today, we explore how early innovators took the first steps toward what would become one of the most impactful technologies in modern history. Cracking the code of the unseen, the struggle to detect and harness invisible signals. Before radar, the world relied on visual observation and sound to detect objects at a distance. Ships, airplanes, and even enemy forces were often spotted by the naked eye or by rudimentary instruments with limited range. But what if you could detect an object long before it came into view? Imagine being able to sense an approaching storm, an incoming aircraft, or an enemy vessel hidden behind the horizon, all without ever actually seeing it. Early scientists pondered this possibility. The idea was simple yet extraordinary. Use radio waves, which travel through the air, much like light, to detect objects by bouncing these waves off them and then capturing the echoes. However, turning this theory into a practical technology was fraught with challenges. Radio waves are invisible, and until then, their behavior was not fully understood. The equipment needed to generate and detect these signals was bulky, imprecise, and often unreliable. Building the blueprint, the early theories that paved the way for radar technology. In the early 1900s, breakthroughs in electromagnetism and radio transmission provided the theoretical underpinnings for radar. Scientists like Heinrich Hertz had already demonstrated the existence of electromagnetic waves, proving that these waves could be generated and detected. Yet the application of these principles to practical detection remained a daunting challenge. Pioneers began experimenting with the idea that radio waves could be reflected off objects and detected by a receiver. These early experiments, though rudimentary, hinted at the potential of what would eventually be known as radar. Researchers had to overcome numerous hurdles: how to generate a strong enough radio signal, how to detect the faint echoes, and how to distinguish meaningful signals from background noise. Imagine the trial and error in those early laboratories. Physicists hunched over bulky apparatuses, meticulously adjusting frequencies and calibrating equipment, all in the hope of capturing the elusive echo of a radio wave bouncing off an object. It was an era of intense curiosity and persistence, where every small success paved the way for a major technological leap. Turning vision into reality, the pioneering experiments that brought radar to life. The first practical experiments in radar began to take shape in the 1930s. Across Europe and North America, researchers were independently working on systems to detect distant objects using radio waves. In Britain, Sir Robert Watson-Watt and his team made significant strides. They demonstrated that by transmitting radio signals and measuring the time it took for the echoes to return, it was possible to determine the distance to an object, even an aircraft flying at high altitudes. Watson-Watt's work was groundbreaking. His experiments provided clear, repeatable results that convinced the military of radar's potential. Early radar systems were bulky and required vast arrays of antennas, but they worked. For the first time, it was possible to see an object without the aid of light, a discovery that would soon change the face of warfare. Imagine the moment when a rudimentary radar screen lit up with the faint blip of an approaching aircraft. In a split second, that blinking dot became the difference between early warning and catastrophe. This was more than just a scientific breakthrough. It was a technology that saved lives and reshaped military strategy. Turning the tide, how radar technology redefined warfare and Allied victory. The true potential of radar was realized during World War II. As nations prepared for conflict, the ability to detect enemy aircraft and ships before they were visible became a strategic imperative. Radar systems were deployed along coastlines, integrated into aircraft, and installed on naval vessels. The early development of radar gave the Allied forces a crucial edge, allowing them to anticipate and counter enemy maneuvers. Imagine the tension in control rooms as radar operators tracked mysterious blips on their screens, each echo a possible threat from the skies. The technology, still in its infancy, rapidly evolved under the pressures of war. Engineers refined the systems, making them more compact, accurate, and reliable. What began as a laboratory experiment had now become a critical tool in modern warfare. The impact of radar extended beyond military applications. It revolutionized aviation, enabling safer navigation and contributing to the development of air traffic control systems. It also paved the way for advancements in meteorology, as radar became essential for tracking storms and predicting weather patterns. Radar was not merely a weapon, it was a transformative technology that touched every aspect of modern life. Trailblazers of innovation, the visionaries who shaped the future of radar technology. The story of radar is also the story of the brilliant minds who dared to dream beyond the visible. Figures like Sir Robert Watson-Watt in Britain, along with researchers in the United States and other parts of the world, were instrumental in turning the theoretical promise of radar into a practical reality. Their relentless dedication, innovative thinking, and willingness to challenge conventional wisdom paved the way for a technology that would alter history. These pioneers worked in environments marked by urgency and secrecy, often under the constant pressure of wartime necessity. Their achievements, however, extended far beyond the battlefield. The work they did in the early development of radar laid the foundation for a host of modern technologies, from satellite communications to advanced weather forecasting systems. Their legacy is a testament to the power of scientific inquiry and the enduring impact of innovation. Igniting curiosity, thought-provoking questions to deepen your understanding of radar technology. As we reflect on the early development of radar, consider these questions. What does it mean to detect the invisible? How can a technology designed for wartime survival evolve into an essential tool for everyday life? And in a broader sense, how do breakthroughs in science and technology continue to shape our understanding of the world? These questions invite us to think about the ripple effects of innovation. Radar is not just a tool for detecting aircraft or ships. It represents a profound shift in how we interact with our environment. It challenges us to look beyond what is immediately visible and to embrace the potential of unseen forces that govern our world. Echoes of innovation, how early radar development continues to shape today's world. Today, radar technology has become an integral part of our lives. Modern radar systems are more sophisticated and compact than their early counterparts, yet they operate on the same basic principles developed over 80 years ago. From weather forecasting and air traffic control to autonomous vehicles and space exploration, radar continues to be a cornerstone of modern technology. The early development of radar not only revolutionized military strategy, but also catalyzed advancements in various scientific fields. Its influence can be seen in technologies that monitor environmental changes, assist in disaster management, and even support medical imaging techniques. The legacy of those early experiments lives on in every radar system that helps us navigate our complex world. Reflect on how a single innovation can spark a cascade of progress. The journey of radar from a secret wartime technology to a ubiquitous part of modern life, is a powerful reminder that the pursuit of knowledge and innovation has the power to change the world in ways we can only begin to imagine. Seeing the unseen. How early radar development transformed our worldview and society. The invention of radar also had a profound cultural impact. It altered the way people perceived the world around them, shifting the focus from what could be seen to what could be detected through technology. Radar changed not only military tactics, but also public perceptions of safety, progress, and scientific possibility. Consider the awe and wonder that radar inspired among those who first witnessed its capabilities. It was a technology that bridged the gap between science fiction and reality, turning invisible waves into a powerful means of detection and control. This transformation of perception continues to influence the way we think about the invisible forces that shape our lives, from electromagnetic fields to the signals that connect our digital world. As we conclude our journey through the early development of radar, let's take a moment to appreciate the ingenuity and perseverance of the pioneers who made it possible. Their work transformed an abstract scientific concept into a tangible technology that has saved countless lives, advanced our understanding of the natural world, and continues to drive innovation today. Thank you for joining me on this exploration into the dawn of radar, a story of innovation, determination, and the relentless pursuit of the unseen. I invite you to reflect on how this remarkable technology has shaped our modern world and to share your thoughts in the comments below. What aspects of radar's early development inspire you the most? How do you see its legacy influencing our future? Until next time, keep questioning, keep exploring, and remember that every great discovery, no matter how hidden, has the power to illuminate our path forward. This is your host from Lost Pages of Science, where the past continues to light the way into our future.